We're going to look now at the segment addition postulate once again. We're going to use it to find the length GH. Now you notice the whole length here is FH, which is 36, and we have FG, which is 21. Therefore, it's pretty easy to find GH just using the segment addition postulate, which tells us that the whole length, FH, is equal to the two smaller lengths, FG and GH, added together. So if we plug in the values, FH is equal to 36 and FG is equal to 21, and we say plus GH, then all we need to do is use the subtraction property of equality to subtract 21 from both sides. And if we do that, we get GH is equal to 15. So again, using the solution the book poses, we write FH is equal to FG plus GH. We substitute in the values, we subtract 21 from both sides, and we get GH is equal to 15. Now we're going to do a question where we graph. I'm going to put a coordinate axis here and mark off 4 in each direction. Now, if you look at the coordinates that are given there, there's something very peculiar about J and K that they have in common, and there's something that L and M have in common as well. Look at it carefully, see if you can figure it out. Okay, if you're not sure, J and K both have the same Y coordinate. L and M have the same X coordinate. Can you see it? Okay. So I'm going to plot these. If you notice with J and K, when I plot negative 3, 4, right here is J, and 2, 4, you notice that having the same Y coordinate gives us a horizontal line. And if I plot 1, 3, and 1, negative 2, where we have L here, M here, you notice having the same X coordinate gives us a vertical line. So if we want to find the length of each, I'm going to give you 2 ways of doing this. One way we can do it is if we want to find JK, we can literally just count. And if you notice, J is 3 spaces away from this y-axis, and then K is 2 away from the y-axis. So if we do that, it's literally 5. The way they want you to do it in the book is to take the absolute value of these 2 x coordinates. So in this case, we can say 2 minus a negative 3, and that's going to give us the absolute value of it's going to give us the absolute value of 5, and the absolute value of 5 is 5. So the length JK is 5. We can do the same thing with L and M. If we look, we can count here and go 1, 2, 3, and then 4 and 5. And if you do it this way, I need to literally see that you're doing that. So L, M is equal to 5, or what you could have done is you could have taken the 2 y coordinates in this case, and you could have said negative 2 minus 3 gives me the absolute value of negative 5, which is 5. So what we can conclude here is 2 things. First of all, we can say that JK is equal to LM, but that's not what they're asking. They're asking, are they congruent? This is telling me the lengths are the same, and when we say JK with a line is congruent with LM, again with the line segment above it, this is basically saying the same thing two different ways. Here we're saying everything about the two lines is the same. At the top, we're saying that JK and LM have the same length. So in this problem, we would actually state this, but this is another way of saying the same thing. Again, looking at the solution here, we have JK and LM. For JK, we use the ruler postulate, and we say -2 minus a -3 is 5. And we do the same thing for LM. We get the absolute value of -2 minus 3 is the absolute value of -5, which is 5. So therefore, the two lengths are congruent. Now we're going to do some guided practice here. See if you can try this. Maybe pause it. See if you get the right answer. I'm going to move right on ahead. And I'm going to say Vx is equal to Vw plus Wx. So therefore, 144 is equal to 37 plus Wx. Subtracting 37 from both sides, we have Wx is equal to, let's see, we'd get what? 107, okay? And again, 107 is our answer. For the next one, again, we want to plot here. So I'm going to move this up a little bit. And you can kind of do this in your head a little bit if you look at it carefully. But I want to see the work for this. So we've got our arrows here. Again, I'm going to go 4 in each direction. 1, 2, 3, and 4. 1, 2, 3, and 4. 2, 3, 4. Okay. And we've got -2, 4. Here's A right here. And 3, 4 here. Here's B. Connect the dots. Pretty close. It's a sketch. And then we've got 0, 2. So there's C. And 0, -2. I'm going to go ahead and do that in a different color just so that you can see it. So it's going to be from here to there. And that's my D. So for AB, we would again take these two values. So we would say AB is equal to the absolute value of 3 minus a -2, which is 5. And for CD, we would take these two values. So we would say the absolute value of -2 minus 2, and that's the absolute value of -4, which is 4. Therefore, AB is not congruent to CD. Thanks.